Hey there, Geometry. Today's lesson is going to be on 11.6 Volume of Prisms. Yes, we did skip 11.4 and 11.5 due to the circumstances and the fact that these two things are not relatively too important to geometry. We're just going to skip right to 11.6. So 11.6 is Volume of Prisms. So let's just talk about what volume is in general. When we talked about, let's say, the circumference or how long the line is, that's a one-dimensional measurement, right? A length is a one-dimensional measurement. That means that you're only going one direction, in this case, left or right in this picture. Now, when we talked about area, we're talking about the space of two dimensions, right? Because we're not talking about not only how far right and left you went, we're also talking about how up and down you are. So that would be two-dimensional. So one is length, which is one-dimensional. Then we talked about area, which is two-dimensional. So now we're going to talk about volume, which I assume you can figure out from the pattern is a three-dimensional one. So three-dimensional, and it's kind of hard always to do three-dimensionals, but three-dimensionals, you're talking about a distance of left and right, which we had here, the distance of up and down, which we had here, plus a distance of, let's say, back and forward. So like, I guess to the camera, we're going towards the camera like that. Like, so that's your 3D. And when we describe volume, that's 3D space. Okay. So volume is just simply a measurement of 3D space, basically a little bit bigger than area. So why or what are we going to do with that information? Well, today we're just going to talk about volume of the prisms. And I might accidentally say area instead of volume sometimes. That's just my bad. It should all be volume today. So let's do volume of a prism. So let's do the easiest prism of them all, which is a cube, okay? So what's really nice about cubes is that if you only have one side length, and then if I remember, every time I draw a cube or something, no matter what year it is, like no matter what geometry level it is, they always say I don't know how to draw a cube. So I don't know, look up a tutorial on YouTube. But this right here is your cube. Now a cube is a squares on all sides, which mean this side length S and this side length S and this side length S are all equal. So when we did a square, if we wanted to find the area of a square, like I said, you would take the length, that one-dimensional, and that height in the two-dimensional, and you will multiply it. So that's S squared. So when you were taking the volume of a cube, is one side times the other side times the other side. So that's side cubed, or side to the third power. That's why it's called cubed. So sides to the third power equals the volume of a cube, okay? Sides to the third power equals volume of a cube. Okay? So let's say, for example, if this was, I don't know, 5. So this is 5 inches. I shouldn't use 5, but it looks like S. Let's use 4. So this is 4 inches, this is 4 inches, this is 4 inches. And I'll talk about inches in particular, I guess, because I just said it. So 4 times 4 times 4, 4, 16, 64. This would be 64 inches cubed. I don't really care about labels in our level, but I just want to tell you the label for 3D shapes are cubed. So it's inches cubed, centimeters cubed, feet cubed, units cubed, all of that. Okay? So that's volume of a cube, which is really easy. It's just side cubed, right? It's whatever your sides are to the third power. So let's talk about something else. Let's talk about a prism. Now, a prism is basically this. You have your 2D shape. Let's take a parallelogram. Okay, you got your parallelogram. And any 2D shape, you just produce a 3D object by going straight up. So you make a 3D object, and then the top is exactly the same as the bottom. So like this parallelogram is being projected upwards. You could do that for a rectangle. You have your rectangle right here. And I'm going to project this sideways just so it's a little bit easier to see. And then you have your other rectangle here. You're projecting it. It's like I took the literal rectangle and pulled it out of the whiteboard. So that's a rectangular prism. This would be a parallelogram prism. We could do a triangular prism. So you have your triangle. Then you project it to 3D space. So I'm like, again, I'm just taking it and stretching it out. So now it looks like a tall triangle. These sides are flat though. So we got that. And then we have, let's say, a cylinder. So we have a circle, and then it's projected out. Any cylinder you've seen, probably like a can or a cup is the cylinder. So you've seen cylinders before. Okay, so those are the basic prisms that we're going to deal with. Now, how do we find area of said, or volume of said prisms? Well, let's take a rectangle because that's pretty easy. Let's take a rectangle here. Well, this rectangle has some amount of space in it, right? It has some area. Find the area of a rectangle is length times width. I don't think anyone's going to disagree with me with that. So the area of this rectangle is length times width. And remember what I say about 3D shapes. It's three-dimensional. So you got your length, you got your width, and you got your depth, okay? So we have our length or width. When we make it a prism, we're just adding this like third dimension by projecting it up and out of the whiteboard, up and out of the whiteboard or the paper you're using. So this third dimension, we're just going to add the third dimension, or not add, let's say multiply into the third dimension. So the area, so this space right here, it's dictated by length times width. And then you have this one, which we're going to call height. Sometimes you could call it depth too, but we'll call it height for this case. So this h is our height. So to find the area of a rectangular prism, or the volume again, is going to be the area of the bottom, which we're going to use capital B. So capital B means the area of the base times the height. So this is your general equation for all the volumes of a prism. The area of the base, which is capital B, times lowercase h, which is just 3D height. Okay? Sometimes you can call it depth too, like how far up or down it is into the 3D space. So for this particular one, what is the formula for the base of the shape? So this is a rectangular base or a rectangular prism. So that formula is length times width times that 3D height. So length times width times height. Okay? So either equation will get you this answer. So you either find the area of the base first and then times it by h, or you could just put it all on one line. Let's do a quick example. Let's do, this is 6, this is 4, and then you have your 3D height being 2, let's say. Well, 6 times 4 is, so then you know your volume is base times height. So let's find the base, which is the 3D area down here. 6 times 4, 6 times 4 is 24, times that 3D height, which is 2. And then it's 24 times 2 is 48. So 48, I guess it would be units cubed. Again, I don't really care for units though. But your answer here would be 48. Okay. Let's take our next shape. Now, because a rectangle is a base, doesn't mean any other shape we can't use as a base. So let's use a triangle as a base in this one. So let's see, I'm going to make a generic triangle, dot, 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 and then a right angle here. Then we're going to take 1, 2, 3, and there's some 3D height, and a triangle up here. Okay. So when we find the base, the area of the triangle, we need the height of the triangle times the base of the triangle. So we use lowercase b. Sadly, we're using height twice, so I'll call this capital H in this case. I'll call this the 3D height, all right? So let's say if for this right triangle. So before I even tell you, this volume equation applies to all volumes of the prism, even if it's a triangle, a circle, a square, a rectangle. Volume is the base of the whole prism times the height. So this shape is the base of the prism. So we got HB times, we're going to call this capital H just because we already use lowercase h. So if I just plug in my numbers, so let's say you have a triangle where this is 10, this looks bigger, so let's do 14. Let's see, and then let's call this 3. First, you want to find the area of the base, which is this space right here. So how do you find the area of this space? Well, you have to think, what is the area of a triangle? Well, the area of a triangle is 1/2 base times height. So I'm going to have to find 1/2 base times height before I multiply by that 3D height. Okay, so volume is 10 times 14 divided by 2. 10 times 14 divided by 2, 100 divided by 2 is 70 times that 3D height, which is 3. So the whole volume is 210. So you're taking your 2D base and just multiplying by the height. In this case, your base was a triangle. Now let's do one with a cylinder. Okay, a cylinder is just the name for a circular prism. So circular prism. So we have a cylinder here with its base being 6, or its radius, I'm sorry, being 6. Now we have to think this is a circle as the base, so this capital B, and let's make this, I guess, 10. And this capital B is the area of the base. So what is the area of the base here? Well, remember, the area for a circle, which we did, before, was pi r squared. So pi r squared h. Okay, so let's take the volume of pi, then we're going to plug in 6 squared, times the h in this case, which is 10. That 3D height is 10. Okay. So the volume, 36 pi. So I found the area of this is 36 pi 10 times 10. And then the volume is 360 pi. Now I could just type that into my calculator. Volume should be about 1130.4. 1130.4. Okay. So that's your volume for a cylinder, okay? So those are the primary shapes of this lesson. I think I'm also going to just post a YouTube of somebody else doing some problems as auxiliary, but this video should be enough to be able to do the work. Yeah. Otherwise, have a wonderful day, guys. We'll see what we go from here, but 11.6 is the lesson of today. Thank you.